Okay, so for the second part, we're going to look at how we can deal with cars that are going both ways on the road. Going both ways. And this part's really complex, so I'm probably going to divide it up in 2 videos. So the first thing we want to do is handle cars waiting just on one side. On one side. Okay. And so what that looks like is we have a road. And then we have some cars on the road, maybe one here, and one here, and one here. And all those cars are going that way. And then we get a car that wants to go this way. And so that car is going to have to wait. And it's going to wait until all these cars exit the road. And then once all of them have exited the road, it can go inside the road. Okay, so this part's fairly straightforward to do. You have your drive road code. And then inside there, there's a call that says enter road. And that's what basically lets cars go into the road. And then we have some stuff later. And so what you want to do is, before you let a call to enter road happen, you want to make a car wait if and only if there are cars going in the opposite direction on the road. Direction on the road. Okay? And that's basically all there is to it. So how would you want to, how do you want to approach that? First, you want to keep track of which cars are on the road. And you want to know what direction they're coming from, so you can either keep track of the direction, or you can have 2 separate variables, one east cars on the road, west cars on the road, something like that. And then however you decide to do it, these are going to be shared variables, because different cars have to be able to access and modify that variable, right? Each car that gets on the road needs to be able to update it, and then each car that wants to go on the road needs to be able to check it. So definitely want to make that a shared variable. And then you also want to think about how to get cars to wait if there are other cars on the road going in the opposite direction. So how to get cars to wait. And by wait, I basically mean to block. And this is when cars are going in the opposite direction on the road. Okay, and again, just like in the last part of the videos, you want to think about doing this with semaphores. Okay? And remember, every time you want to deal with a semaphore, you want to think about what value should you initialize them to. Initialize. Right? Is it 0, is it 1, or is it some number greater than 1? And you guys all know what those values mean already? Okay. And then you also want to think about when you want to signal that semaphore. And so to know when to, last time we signaled when we knew that we had left that position on the road, right? And so this time we want to signal, you always want to signal when the condition that you blocked on is no longer true. So in this case, the condition that we blocked on is that there are cars in the opposite direction. So I'll just write that down. Condition we blocked on is cars going opposite direction, right? And so you want to signal when this condition is no longer true. because you're telling a car, all right, what you blocked on, what you waited on, it no longer applies, so you can go ahead and enter the road. Okay. So, since we're using shared variables here, a note about shared variables. You have to realize that more than one process, and here processes are basically cars, so more than one car can access or modify them at the same time. Okay, and so if you remember from the synchronization lecture, this sometimes can lead to problems, which we know as race conditions or data races. And so you might want to think about if you need to add protection to those shared variables, like the number of cars on the road, and how you might want to go about protecting them. And so for this part, you want to remember that how we did that in lecture is through the use of mutexes. And you might want to look at those again to see how they're used, but a mutex is basically a semaphore that you initialize to 1, because a shared variable is something that only one process can access or modify at the same time. Okay? And then since we're going to be using semaphores and mutexes, a note about those. That is a really easy mistake to make. Semaphores and mutexes. And remember, mutexes are just semaphores that we initialize to 1. To protect shared variables. You want to be very, very careful about deadlock, which is really, really easy to happen. Deadlock. Okay, so let's just review for a little what exactly is deadlock, what does it mean? What is deadlock? Okay, so this definition is kind of long. I think it's longer than what you have on the slides, but it explains it a little bit more specifically for this project. So deadlock is when you have one process that is blocked and that process that is blocked is holding on to a resource. Or, in other words, it's locking that resource. Locking a resource that a second process needs to unblock the first one. The one that was blocked. Okay, block the first one. So this is not exactly the definition of deadlock, but it's basically the most common occurrence of deadlock in PA3 for you guys. So let's look at an example of what exactly this means. Okay. Let's go through a simple example of general synchronization where one process has to wait for a second process to do some setup before it can continue. So we're going to have a variable called setup done, and it's going to start out being false because the setup is not done yet. And then we're going to have a mutex to protect this variable, and we're going to initialize that to 1 because mutexes, that's what they're initialized to. And then we're going to have a semaphore so that the process that needs to wait can block. And we're going to initialize that to 0 because, remember, initializing semaphores to 0 means that first process to call wait blocks. Okay? So then we have, and setup done is a shared variable in this case. So we have our first process, and then we have our second process. And P1 is going to call is going to check if the setup is done. So if the setup is not done yet, it's going to wait on our semaphore. And remember, this is going to cause it to block because we initialized it to 0. And then process 2, and then afterwards it's going to do some stuff. And process 2 is going to perform some sort of setup. And then it wants to set setup done to true, so that process 1 knows that it can go through. And then, just in case process 1 did block, it wants to let it know that it can continue now. That condition on which it blocked in is no longer true. So we go ahead and we signal sem. Process 1 can go because the setup is now done. Now remember, setup done is a shared variable, so we want to protect it with a mutex. So before and after every access, we want to call wait on a mutex, and we want to call signal on a mutex. And before and after every modification, we want to call wait and signal. Whoa, what happened? Okay. Wait on the mutex and signal on the mutex. Okay. Cool. Now, really reasonable looking code that has a deadlock problem, and let's look at how that can happen. So let's keep track of what the value of all the variables are. So what mutex is, and what sem is, and what setup done is. And then maybe let's also keep track of who is blocked. What processes are blocked, like waiting on some semaphore. Alright, so let's look at what we initialize stuff to. Let me go back up. We initialize setup done to false, mutex to 1, and semaphore to 0. Okay, so mutex was initialized to 1, semaphore to 0, setup done to false, and no one is blocked at the beginning. Okay, so let's assume I start being process 1, and then I call wait on my mutex because I want to access it. So my mutex value is now 0, and that's because process 1 called wait. And then I check if setup isn't done yet, and then setup isn't done yet. So I'm going to call wait on sem. So the value of sem is going to be -1 because p1 called wait, and because -1 is less than 0, we're going to block. So p1 is blocked on sem. Okay, and so we blocked right here. So now since we blocked, we go to P2, and P2 is going to perform some setup, and then it wants to set setup done to true because it's done doing a setup, and it wants to signal sem because it wants to let P1 know that it can go. But before that, it needs to wait on the mutex because it has to access this setup done variable, which is shared. So it's going to call wait on this mutex. The value is going to go down to -1 because P2 called wait. And because -1 is less than 0, P2 is going to block on mutex. Okay? And so here is an example where we got deadlock. P2 can't tell P1 to go because it's waiting on the mutex that P1 is holding, and P1 can't go because it's waiting on the semaphore that P2 was supposed to signal. And this is a really easy mistake to make. So how do we go about avoiding deadlock? Oh, how did I do that? Okay. How to avoid it. Well, the main thing, and this is true of like any time you're using semaphores or synchronization stuff, you want to release all the resources that you no longer need, that you've already looked at or you've already modified. You basically want to keep your critical section as small as possible. No longer need. Okay? And then you want to make sure that you release these resources before you have a possibility of blocking. Okay. And by blocking, I mean waiting for some other semaphore. Semaphore. Okay? So let's look at an example of how the old code would look like if we applied this technique. So for example, okay, we have again P1 and we have P2. And just like before, P1 is going to check if the setup is done. If it's not done, it's going to call wait on sem so that it blocks. And then afterwards, it's going to do some other stuff. Okay? And then P2 is going to do some setup. And then it's going to call make setup done be true. And then since setup done it's true, he's going to signal on sem to let P1 know that it can go, to unblock P1 basically. Okay, and now we want to add synchronization. So, for P2 it's pretty straightforward. We want to wait every time before we access on our mutex. And we want to signal once we're done accessing. And this is a really, really good example of what a critical section should look like. You have your wait and your signal, and your critical section is just a single line of code, which is this line right here. So it's really small, and that's good. Now for P1, it's less straightforward. We're accessing setup done, so before we access it, we should wait on our mutex. But before we wait again, right, because here when we wait on another semaphore, we might block. And if we block, we run into the problem that I described earlier. So before we wait, and since we're done accessing, we want to signal on mutex. Right? So we've released that resource before we call wait on some other semaphore. And so that basically makes it so that we don't hold it while we're blocked waiting for someone else to do something. Now the problem here is that we're only signaling if we go inside the if. But we also have to signal if this condition wasn't true and we skipped the if, right? Okay. So we want to add an else, because through every path of your code, you want to make sure that you signal. And in this else, we're going to signal our mutex. So that way, if you go inside the if, you signal, and if you don't go inside the if, you go into the else part and you signal. You don't want to just put it after the if, because then you would signal twice if you go inside the if, right? So you kind of have to do this if-else structure. And the real problem here is this line, because it's what makes us block. Like, this line means we could block without releasing the mutex. Oh, what happened? Okay, mutex. If we didn't have that line, otherwise, then you could have a single wait and signal. wait signal that surrounded the entire if. I don't know why my computer is being so odd. Surrounding. Okay. If would be fine. Right, one before the if and one after the if, and that would be okay. No? Okay. I'll just do that. Cool. Okay. And so I think that is all you guys need to take care of this one case. And in the next video, I'm going to talk about what happens when we have cars waiting on both sides of the road. And so that's when you want to do the whole taking turns that the spec describes.